So today I have something a little different for you. So my mate David bought himself an SV1000 with about 40,000 Ks on the clock. Upon riding the bike, he discovered it had one ungodly vibration between 2 and 4,000 RPM. After a quick Google diagnostic, we discovered that this was a common fault with SV and DL1000 Suzuki motorcycles. Long story short, the clutch basket has a really crap design and it flogs out real quick and leaves heaps of radial play, which in turn makes the bike vibrate like hell between around 2 and 4,000 RPM, and when it gets bad enough it almost makes the bike too uncomfortable to ride in that rev range. Downright not enjoyable. So today's plan was to bore out the clutch basket and then take this piece of bronze measuring 55mm OD and hit it smack bang in the middle of there with a nice press fit. We would also replace the rivets with some M10 low profile cap heads. So it was over to the lathe to dial the piece of bronze in using the 4-jaw chuck and a dial indicator. We wanted to get this within 0.01 of a millimeter, so the OD and ID were both as concentric as possible.
Yeah, fuck mate, that's about 5 microns.
So before we could bore the bearing, we needed to know how big the shaft was running inside of it, and it was 49.97mm. So we decided we would bore the bush out to 50.00mm, leaving a little bit of clearance. Now the boring bar we selected for this, as we were pretty limited with options, was a hardened steel insert. Now the reason I chose this was because it has a fairly neutral rake, and most of my other inserts are either general purpose or designed for aluminium. So I had a few to choose from and we were going to see how we got on. Seeing as this was the first precision job I've had in a while, I decided to wheel out the big guns, the micrometer and the telescopic gauges. Once we got the part turning in the lathe, the insert left an awesome surface finish and we just worked our way up to the final dimension, measuring along the way. Once there, we parted it off to length. After we finished that, we changed the hardened steel insert for an aluminium insert with a very positive rake, which would leave a nice clean cut. Once we had done that, we chucked the clutch basket up in the lathe, and the best we could get it was about 0.1mm, 0.15, and that is due to the fact the hole is probably shaped like an egg. It is so flogged out, I doubt it is running true. So we followed the exact same process for the basket, taking incremental cuts and measuring along the way to make sure we were removing what we thought we were, comparing the DRO with the micrometer readings. Once we were happy, we snuck up on a 0.3mm interference fit. So we rested the clutch basket up on this fork seal driver and then got our new bronze bearing, and all that was left to do was heat up the basket and drop the bearing in. David had little faith that the basket would grow enough to drop in the bearing, which was 0.03mm oversized.
Woo-hoo-hoo! Look at that, he's one happy man.
From there, all we had left to do was reassemble the basket in the correct order and then apply some red thread locker to our M10 cap heads. David came up with a number, 33 Newton meters. I don't know where he pulled that from, but that's just what we hit it with, and as you can see, the basket turned out perfect. There is absolutely no discernible play, and David has now installed the clutch on the bike and it runs perfectly with no vibration whatsoever. So this fix turned out awesome and saved my mate a few dollars in the process. Thanks for watching.